Okay, kids, we are now doing graphing trig functions. So I'm going to try to condense this lecture as much as I can. I may or may not split this up into 2 lectures, but I don't know. We'll see. I'm going to try to do my best. Alright, so this is 5.3, graphing trig functions. 5.3 is sine and cosine, and 5.4 is tangent. So we're going to do as much as we can. The homework that's due tomorrow, no, the homework that's due Wednesday from this lesson is just sine and cosine, and then tangent will be later, but whatever, we'll get done what we can get done in this lesson and go from there. And we'll continue with it in tomorrow's lesson and Wednesday's lesson. This is confusing. This is Tuesday's lesson. Wednesday we will do more graphing. Sweet Jesus. Alright, here we go. So consider the function f of theta equals sine of theta. So again, I am using theta just so you can get used to the idea that we are really plugging in angles into these trig functions. This is the same as if I said f of x equals sine of x. It doesn't matter what variable I use for my input. Okay, I could say f of alpha equals sine of alpha. I just don't want you to get confused with sine being the y value and cosine being the x value. This just represents an input. This is just the input symbol, any variable. Okay. Alright, so anyways. So my input is theta, okay, and my output is f of theta, or sine. Okay, so that's what we're going to plug into. We're going to plug into the sine function. So if I plug in 0, I want sine of 0. It's like, well, where do I find that at? On the unit circle. If I want to find sine of a number or cosine of a number or whatever, I'm going on the unit circle. You go on the unit circle, and I'm not going to show all this because I need to shorten these notes. But you should know sine of 0 is 0. Okay? I'm going to go down the list quickly. And again, these will get posted. Plug in 1, sine of 1. Alright, now I can't help but the teacher and me to show not to forget these spots on the unit circle. Okay, there's 0 miles. So sine of 0 is 0, okay, the y value. And then if I want to go 1 mile, remember pi over 3 is about 3.14 over 3. So that's a little bit more than 1. That's like 1 point something. I want to only go 1 mile. So we did that yesterday, or we did that on the part 1 video. This is part 2 of 2. We did that on part 1 video. If I walk 1 mile, that's about this far. There's 1. Okay, so that's an approximation. Sine of that is about, okay, you go up about 0.8. Okay, go up about 0.8, so it's about 0.8. Alright, and I'm not going to show the rest of them because you should know the rest of the famous guys on the unit circle. Sine of pi over 6 is 1/2. Sine of pi over 4 is square root of 2 over 2, which is approximately 0.7, and so on and so forth. Sine of pi over 3, so plug in pi over 3, that's my x value, and you get out square root of 3 over 2. Okay, so these are your x values, so these are your inputs, and these are your outputs. Okay. Sine of pi over 2, that's 1. Sine of 3 pi over 2, it's negative 1. Okay, pi over 2 is here. What's my sine value there? It's the y. Bam. 3 pi over 2. What's the y? Negative 1. Okay. Sine of pi. There's pi. What's my sine value? 0. Okay. Sine of 2 pi. What's my sine value? 0. Okay. So your unit circle is where you get your coordinates. Okay. You plug in the pi guys, and you get out your, in this case, the y values because it's the sine function you're grabbing. Okay. Your unit circle is where you get your coordinates. Okay. Plug in pi guys. And get y values because f of x equals sine of x, or theta, or whatever. So we're working with the sine value. Okay. So this unit circle is to strictly get your input and output values. Okay, we have that table. Now we're actually going to graph this function. So now we're going to go on an xy axis and actually graph this sine function. Okay. Alright, so what does a sine function look like? So we know polynomials, we know those are like curvy curves. Okay. We know parabolas are u's. We know that absolute values are v's. Okay. Now we want to know what a sine function looks like if we graph it. And if we went down this whole list, it would start like this. If I plug in 0, I get out 0. So that's 0, 0. If I plug in pi over 6, oh, that's weird. Pi over 6. Pi over 6 is a weird number. Okay? So, that's like 1. Pi over 6, what's pi over 6? That's 3.14 about over 6. That's about a half. So I go over to the right 1/2, and I go up 1/2. Because pi over 6, sine of pi over 6 is 1/2. So it's about right there. Okay. So I would start to plot these points. Pi over 4, that's bigger than a half, and then 0.7, so it's a little bit higher than a half. Okay. So I would plot a bunch of points, okay, and I'm not going to do it all because of time. However, when you plot these points, you start to get this really pretty curve. And here's the points I do want you to graph. I'm going to erase that. And you're going to see why. So we have 0, okay, pi over 2, comma 1, 3 pi over 2, comma negative 1, pi, comma 0, 2 pi, comma 0. So I'm going to actually put those on there. So here's 2 pi. Alright, ignore that 1, but it's there. In between 2 pi and 0, so this is 0, is pi, right? Halfway between 0 and 2 pi is 1 pi. Halfway between, oh, I didn't put this to scale, but whatever. Not whatever, but pi over 2. Okay. My points aren't to scale because of how I did this. Half of pi is pi over 2. And then, if this is 1/2, okay, this increment is 1/2, this is 2 halves, that means this is 3 halves, or 3 pi over 2. Okay. So I cut this up. So what I did was I took a candy bar. Okay, remember 993? If I took one whole candy, this one cycle. Okay, now let's get used to periods and cycles. If I took one candy bar and cut it into fourths, that's what I did. Okay, I cut that into 4 pieces. But this is 2 pi, and then half of 2. So I'm going to show you on this candy bar. So if here's my whole, there's 0. I cut it into 2. If I cut it into half, that's 1. If I cut 1 in half, that's 1/2. And then I counted 1/2, 2 halves, 3 halves, 4 halves is 2 pi. You just throw a pi on there. Okay, so I cut this candy bar up. Okay, that's what I did. Alright, so, and we'll practice that, but these are going to be the nice spots. So, plug in 0, you get out 0. Okay? Plug in pi over 2, you get out 1, so you get out this point. Pi over 2, comma 1. You plug in 3 pi over 2, you get out negative 1. So, go over 3 pi over 2, down negative 1. You plug in pi, you get 0. So, to the right pi, up, down 0. And then to the right 2 pi, up, down 0. Alright, now if I would have actually graphed all these points, okay, and there's a bunch more in between, all the famous points on the unit circle, had I graphed all the famous guys on the unit circle, they would have filled in this graph and it would have looked like this. So all those famous spots on the unit circle would have made that graph. I just didn't show them all. Okay. Luckily I have it done already, so I'll give you a sneak peek real quick. That's what it would have done. See all those points, all those famous points on the unit circle? All of those guys? If I would have plotted them one by one by one, that's the curve it would have made. Okay. I'm just showing you the 4 spots you're going to need for your sine function. And I do want you to tell you that this goes on forever and ever. Okay, keeps going because you can go around the circle forever and ever and ever. And it goes on this side too. Okay, so that's a harmonic function. It goes on forever and ever and ever, and it keeps that shape, that nice sine curve. Okay, let me highlight this. This is from 0 to 2 pi. That's 1 cycle. And that's what you're going to be graphing, 1 cycle of these. So I'm not going to keep having you go on forever and ever and ever. So that is 1 cycle or 1 period. Okay, and we're going to talk about the period and all that stuff. I just needed to see where that graph came from. Alright, now that you see where that graph came from, our inputs and outputs come from the unit circle, and then we plot those x and y numbers. What I need you to understand is this. This is a regular xy axis. Okay? We're just having weird inputs. We're not used to having weird x values to plug in. We're used to plugging in 5 and 7 and -2 and 1/3. This time we're plugging in pi's. It's still the xy axis. Okay? It's still the xy axis. It's just that we're plugging in weird inputs. But that's still the real number line. So don't get freaked out about that. Okay? It is totally still the real number line. Alright, so let me give you the rest of these guys so you can see what the other trig functions look like. So I just want to make a note here, this goes on forever. In both directions. Okay, in both directions. Alright. Turn this over. Let me show you your cosine graph. I'm just going to do that quickly because of time. So I'm just going to write this down. Sine of x, f of x equals sine of x. Again, don't get confused by the x. It's just the input thing. It's easier to just draw the curve like that and then fill in. I'm going to talk about these numbers, what all this means. So this lowest point right here, this point down here, that's this 3 pi over 2. And then this highest point, this guy right here, that's the pi over 2. So these, and that's 0. Those are going to be the 5 spots you're going to have to label. Okay, there's your sine graph. That's your basic sine graph. And we're going to fill in a little bit more information on that. Now we're going to do our basic cosine graph. So f of x equals cosine of x. And we would do the same process in input-output table. Okay, we'll get our inputs and outputs. And it turns out cosine looks like this. That's your cosine graph. So, for example, let me just show you very quickly, because the teacher in me has to do it. If I plug in 0 into my function, I plug in 0, cosine of 0, what is cosine of 0 on the unit circle? So get from unit circle. Oh, it's 1, so plug in 0, you get out 1. If I plug in pi over 2, plug in pi over 2, so cosine of pi over 2, that's my input. My output is now whatever this value is. What's pi over 2 on the unit circle? Cosine value is 0. So that's why you plotted 0. If I plug in pi, go on the unit circle, cosine of pi is -1. That's why you got that point out. Okay. If I plug in 3 pi over 2, cosine of 3 pi over 2, what does that equal? Go on the unit circle. That is 0. So go over to the right 3 pi over 2, up, down, 0. And last but not least, if you plug in 2 pi, cosine of 2 pi equals, go to 2 pi in the unit circle, what's that value? 1. Go over 2 pi, go up 1, plot your point. That's where that comes from. Okay? So it looks like a sine graph. Remember, this goes on. It is continuous as well. But we're not going to go on forever and ever and ever in left and right direction. I only want one cycle. That's one cycle or one period. So that's what we want. Alright, that blue color is terrible. I'm going to stop using that. So those are your basic sine and cosine functions. You got to know the difference between them. They have almost all the same information, but their graph starts and ends at different peaks. Okay, so let's talk about this. Let's get some more information. And this is going to go for the sine and cosine function. So the domain for both of these guys. What are you allowed to plug into a sine function and cosine function? You can plug in any numbers. 1, we did that on the unit circle. That's an approximation. 3 pi, sure. So your domain is all reals. Your range is what's weird for sine and cosine. If you look on the unit circle, on that unit circle you cannot ever get a value bigger than 1 or smaller than -1. So you're restricted. Your highest point is always going to be 1. Your lowest point is always going to be -1. So for your trig functions, your range, the output you get for sine and cosine, -1 to 1. Nothing bigger than 1, nothing smaller than -1. The period, that's how like wide your graph is. Okay, like that's the measurement. So this measurement or how wide it is 2 pi. And that's for your basic. This is all your basic information. This is what you're going to start with. Domain's always going to be this, but your range could change and your period could change, and you're going to see how. But for your basics, this is what you start with. Okay. And then the amplitude. Oopsie. Alright, that's like the height of your graph, if you want to call it your height. Your amplitude is 1 for your basic. Okay, and it's like, how do you get that? You do the highest output minus the lowest output and divide by 2. That's your amp. So highest is 1, lowest is -1, divide by 2. 2 over 2 equals 1. That's your amp. And we're going to see where to get the amp from the function, how to get the period from the function. We're going to figure all this stuff out. Okay, this is all the stuff you're going to need. So you're going to need your 5 basic points, and then your period, your amp, and all that stuff. So we'll get into all that. But there's all your basic information for your sine and cosine graph. I'll hold off on tangent for right now. Let's get used to this stuff first. Okay, so we'll go from there. So just like you have all your other graphs memorized, what does an absolute value look like, what does a root look like, what does a parabola look like, or quadratic, whatever. Now you got to know these basics too, with all this basic information. Just like for your log and exponentials, you got to know your critical point and you got to know your asymptote. Now for here, you got to go know your amp, you got to know your new period, or if you have a different period, and then you have to have these critical points that I have listed. Okay, so more information. So we'll talk about tangent later. Let me get into some sine and cosine. Alright, because these videos have to be short, I'm going to actually just give you all the information and then go through the different transformations and all the information like that. So let me get you just like a basic function. Sine or cosine, it doesn't matter. So info from function. So I'm just going to give you a basic one. So f of x equals a sine of bx plus c plus d. Okay. So you could have a coefficient in front. You could have a coefficient in front of the x. You could have a shift type looking thing and another shift type looking thing. Okay. So this is where a, b, c, d are integers. Okay. That z is integer. That means an element of. So that means they're just numbers. Okay. They're just numbers. Alright, so let me tell you what this information tells you. Okay? Your A equals the amp. Okay? That's going to actually tell you your amp, how the height of that guy, the highest point and the lowest point. And if A is negative, you know you have a flip. So negative A, you know you have an up-down flip. And we're going to do examples of these. So you already know if there's a negative in front of the function, it's an up-down flip. Your amp is still just the A part. That's all you need to know. You ignore the negative. It's still just A. And we'll get into examples. Your B affects your period. Okay, so your period, if you have a number in front of the x, your period is no longer 2 pi. Okay, you're going to have a new period. And you're going to have to factor B out. And we're going to get into this. I'm just giving you this information. And your new period, okay, will equal the old period over B. You actually divide by that coefficient. That's going to tell you your new period. Your C will equal your left-right shift. So why do I put C in quotations? Because you have to factor B first. Factor out B first. Okay. Factor out B first. I'm going to put positive B, positive B. I'm going to factor out a positive B. Because if this was negative, okay, so if you had a negative B, that would be a left-right flip. So you already know anything in front of the x, a negative in front of the x is left-right flip. But we're only going to factor out positives. I know it's kind of confusing right now, but I'm getting all the information down. And then finally, your D will equal your up-down shift. So that's what all those variables are. So let me go back over this. Your A is your amp. Regardless of the sign, the A is the amp. Okay? If there's a negative in front of this function, you know you're going to do an up-down flip. The B affects your period. Okay? So we got to factor out the B first. And then once you do that, you're going to do the new period equals 2 pi, which is the old period, over the B. And that's going to give you your new period. Your C will be your left-right shift, but you got to factor out B first. Okay? But factor out a positive B first. So you're going to leave the negative on the inside. If your B does happen to be negative, that just means you have a left-right flip. So the number in front of x is still a left-right flip. The sign. And then D is your up-down shift. Okay? So we're going to do all these flips and shifts and have to look at this period and all this stuff. And we'll do it little by little by little. So that goes for your sine function and your cosine function. And it'll go for your tangent. We'll talk about all that. We don't graph secant, cosecant, or cotangent. Okay. Alright. Let's get into some actual graphing. Alright, I'm going to take it one by one by one. I'm going to try to go a little bit fast just to get through these notes. So, graph. Here's A. F of x equals 3 sine of x. Now, before we plotted points, right? In that first example we plotted points. We're not plotting points. We're going to use all our information. Okay, that's what we're going to do. So, we're going to take all the information we know about sine and cosine and everything else. This 3 is your amp. Your amp equals 3. It comes from that. Regardless if it's positive or negative, that's your amp. So that's going to tell us our highest and lowest point. Okay? Everything else is normal. There's nothing else. Okay? If you do shift, flip, flip, shift, you got none. None, none, none. Like, there's no left-right shift. There's no left-right flip, no up-down flip, and no up-down shift. So, the only thing that changes from your basic function to your new function is the amp. Okay, so then you draw your graph. So, let me write this down. My period, nothing's affected my period, so it's still 2 pi. So, this is a sine function. But my amp is no longer 1. So, on the old graphs, on your basics, it was 3, or is negative 1 and negative 1. Now it's 3 and negative 3. That's your amp, your highest point and your lowest point. That's it. That's what that tells you. Bam. That your top of your graph is going to hit 3, the bottom of your graph is going to hit -3. That's what your amp tells you. So I literally just draw in the cosine function, or sine function. It's that curve. The highest point 3, the lowest point -3. It always starts at 0, 0. And your period is 2 pi. So you go from 2 pi. That's one cycle. That's all we're drawing is one cycle. And then you have to put in the rest of the points. Well, your period did not change. So the rest of the points are as they go. So half of 2 pi is 1 pi. Halfway between 0 and pi, so that peak, that is pi over 2. Okay. And then if you count 1/2, 2 halves, which simplifies to 1 whole. Remember, there's pi's attached to these. 3 halves, so I'm literally counting halves. That's 3 pi over 2. And then 4 halves, which simplifies to 2 pi. So I just cut them up, I benchmark them, and then I count my fractions. So let me do it again. Half of 2 pi's is 1 pi. Half of 1 whole pi is 1/2 a pi. And then I count my fractions. This right here, this increment, that's what everybody split up into equally. Okay, that's the same increment across the board. So it's halves, so we count it by halves. 1/2, 2 halves, 3 halves, 4 halves. And stop. So you have to have those 5 spots. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so there's your graph. That's done. Alright, B. G of x equals 4 cosine of x. So, you go through it. Your amp is 4 now. Your period is still 2 pi because nothing's in front of this x, and you have no flip, shift. None of that stuff. So what happens with these guys is this, with these coefficients in front, okay, it stretches them. So it's going to make it really skinny. So it's going to like elongate this cosine graph because I have to hit 4 and 4 out. I usually only have to hit 1. So it's usually like right here is my graph. Now I have to stretch it to hit 4 and -4. So again, your cosine graph starts at the top and then you go down, so it's skinnier. That's a cosine graph. That's it. So you're stopping right there. And then you label it. 2 pi is your period, so that's the biggest output for our one cycle. That's that end. In the middle, so this valley down here, half of 2 pi is pi. Right here at this cut, that's really halfway. My graph's just not perfect, but halfway is there. That x-intercept, that's pi over 2, and that's 3 pi over 2. So pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So those are your spots. I don't know why I colored that in. You have to have labeled. This is what Logan was asking about in office hours. Those spots. That's 0. That 0 is going to help you. Later, when we do shifts, you're going to need that 0. So put it down. Okay? Alright, so that tells you about your amp. Let's do some more. Okay? Here's C. Now that things affect your period, okay, so let's graph h of x equals sine of 2x. Alright, now the number's on the inside. Before, on the outside it's your amp, on the inside it's going to affect your period. Okay? Sorry, I needed some water. Alright, and I told you on the last page that you were going to have to factor this out first. So let's practice this. So my amp is 1 because my coefficient is 1. Now my new period. Okay, so I need to factor out first. So I'm going to have h of x equals sine of 2 times x. That's what I mean by factoring out. It does not go in front, so be careful. It's just in front of that. And then I'm going to be able to get my new period. If I had a flip, this was negative, I would leave the negative on the inside. We'll do examples. You only factor out that positive guy. Okay? So my new period is 2 pi over b. Well, in this case, b equals 2. That's from that guy. Okay? So my new period equals 2 pi over 2. Simplify that, that's pi. So my new period is pi. That's how wide my graph is. It only goes from 0 to pi. Okay, that's my new period. So I'm going to draw my graph. Okay, again, I'm only doing one cycle. My amp is 1. Highest point is 1. Lowest point is -1. Okay, there's my amp. And my new period, so I'm going to draw this in. So this is a sine graph. Still goes to 0, 0, still goes down, still goes like that. So you just draw it in. But now my new period is pi. That's how wide it is. So now I have to find, this is the fun part, the rest of the famous points. This is 0, still at 0. And now I'm just going to do fractions. Okay? If this is pi, this is the halfway mark. What's half of pi? Okay, half of pi, half of pi. That's half. That's multiplication, that's pi over 2. Okay, so this is the pi over 2 marker. Think about the unit circle. If you go from 0 to pi, okay, this is 0 to pi, halfway there is pi over 2. Okay, think about that unit circle. This is pi. Half of pi, so what's half of that? Half of pi over 2, I mean. That's 1/2 times pi over 2. You just multiply them together. It's pi over 4. When you do a half of something, multiply by a half. Pi over 4. Sorry, that point is not there. It's pi over 4, comma, 1/2, or comma 1. Okay. Alright, and then this last guy. So now that you have this marker right here, you know everybody's in fourths. So from here to here is 1/4. From here to here is 1/4 increment. So 1/4, 2/4, which simplifies to pi over 2, 3/4. 3 pi over 4. And this guy better be 4/4. Oh, yep, it is. 4/4 simplifies to just pi. So I cut it in half again, and then count up. Or the same thing as to add these two. 1 pi over 4 plus pi over 2, get a CD, you get 3 pi over 4. Remember how I used to do 993. Okay? So that's what happens when your period is affected. This number in front of the x affects your period. Then you have to go find your new famous points, critical points. So amp affected, period affected. I'm just giving you a minute to get all that in while I get my notes. Alright, let's go to D. I don't know how I'm supposed to make these videos short. This is insane. F of x equals 5 sine of 4x. Now my period and my amp. Alright. So amp equals 5. Bam, done. Just look at that number in front. Period. We're going to have, let's factor this out, 5 sine of 4 times x. So period equals 2 pi, that's the old period, over 4, which equals pi over 2. So that's my new period. Okay, so my graph only stretches out to pi over 2. Alright. Draw in your period, or sorry, your amp, 5, -5. I draw my graph in. Highest point is 5, lowest point is -5. Actually, I'm going to stretch this out. Get stretched out a little bit more. Okay. So this is pi over 2. That's the width of your graph. It's the highest, biggest piece of your domain. Okay. Again, because we're only doing one cycle. It goes on forever, but I only want one cycle from 0 to pi over 2. So now we got to find this halfway mark. What's half of pi over 2? Pi over 4. Okay, you just multiply. Half of pi over 2, 1/2 times pi over 2, that's pi over 4. That's all I'm doing. Okay, multiply by half. What's half of pi over 4? Pi over 8. Pi over 8. Okay, half of that is pi over 8. And then count. 1/8, 2/8. Oh, this guy's got to be 3/8. So you label 3 pi over 8. and this guy is 4/8, and that better simplify to, oh look, pi over 2. It does. So I just count my fractions. Or again, you could add these two and it equals that spot. It's up to you. So you're done. You've graphed it. Amp is 5, your period is pi over 2. E. Keeping it moving. I want to do one shift. This shift gets nasty. Alright, let me do a basic one before I get into that nasty one. H of x equals cosine 2 cosine of x minus pi over minus pi. We'll just do minus pi. Okay. Alright, so here we go. So now we have a shift in there. Okay. Alright, here we go. Amp equals 2. That's the number in front. Your period, well, there's no number in front of x, so it's just 1. So if there's no number in front of x, it's just your original period, which is 2 pi. Okay. But now you have a left-right shift. Okay, so now we have shift, flip, flip, shift. We're going to go left, so we got a left-right flip, we're going to go right pi. That's that guy, right pi, so still the opposite. Left, right flip, no, there's no negative in front of this x. Up, down flip, no, there's no negative in front of the function. And up, down shift, no, because there's no plus or minus on the outside. Alright, so this is what you do. You start with your basic. We're going to need the basic to do these, because now we have shifts involved. Okay? So my basic, and I always start with my period, so I'm going to put quotations, basic, I'm sorry, my amp. Your period is still the same, but you can throw in your new amp. It's 2 and negative 2. Doesn't matter. Okay, it's fine. And you get your 2 pi is your basic period. Okay, before the shift. This is before shift. Then you have pi, pi over 2, 3 pi over 2. You got to get all those points. Put 0 down. Because now we're about to take this whole graph and we're going to shift it to the right pi units. That's what that's saying. We got to go right pi units. Instead of going right 5 or right 1, it's right pi. Okay? Alright. So here we go. I'm going to label these. This is how I show it. Let me get a different color going here. And I'm stretching. Get that down. You guys can look at that. Alright. So, there's a lot to keep track of when we do left-right shifts. It's annoying. So I'm going to label these. This is A, B, C, D, E. So I know my starting of my graph is at A, my ending of my graph is at E. Okay? B is my highest point, D is my lowest point, and C is that halfway mark. We're going to need to keep track. Because we're going to shift all of these numbers to the right pi units. So I'm going to keep track of it. A is 0 plus pi. So right pi, so you're going to add pi to 0. You're going to add pi to each one of these x values. B is pi over 2 plus pi. C is pi plus pi. D is 3 pi over 2 plus pi. And E is 2 pi plus pi. Okay? I got to add pi to each of these guys. Alright, here we go. 0 plus pi is pi. Pi over 2 plus pi, you can get a CD, you can do it in your head, but that's 3 pi over 2. I'm just going to leave them as fractions. Okay. Pi plus pi is 2 pi. 3 pi over 2 plus pi, you get a CD, do it in your head, that's 5 pi over 2. Okay, so that's 2 over 2. Yeah, then do it in my head, and then there's 3 pi. So those are going to be your new famous spots. Okay. because we're shifting everybody to the right pi units. Alright, now we gotta graph this. So they take some thinking. So our what you call it is still, our amp is still 2. And now my starting point, my A, this bottom piece of the graph, is shifted over to pi. Okay, so it's going to start here at pi units. So it's actually, let's be correct about it. It's going to be here. My starting point is here. There's pi. Okay. So it's going to go like this. I've shifted over. Okay. I'm going to make this accurate. I'm going to make it right below that other graph. So there. So I took this guy and I shifted it over. Alright. 2, highest point, lowest point, -2. Alright, so I just did the curve and now I'm going to fill it in. So my A, my lowest point is 0. My highest point is 3 pi. This guy is, so there's A, this guy's B, this guy's C, this guy's D, this guy's E. Alright, B, 3 pi over 2. C, 2 pi. Okay. Oh, that's not 0. That's pi. Okay. And D, 5 pi over 2. And does that make sense? What's halfway between 1 pi and 3 pi? Oh, 2 pi. Oh, look at that. Okay, so that does make sense. Alright. There's everything labeled. Your period's labeled, your shift, your amp is labeled. That's your new graph. That's a left-right shift. That's why they're annoying. Okay, you're going to have to do that math to get all those famous critical points, all those spots. Just giving you a minute to let that sink in and look at all that work. Alright. Let me do an up-down shift. A, B, C, D, E, F. You know what? Let me pause this, because this is long. It's a lot. I'm going to pause it. We'll get to the up-down shifts in a little bit.